All right, this lesson is on Punnett squares. Now we've been talking about genetics and we've been talking about Gregor Mendel and how he became the father of genetics. Now we're going to move on to Punnett squares, which is actually a chart, a organizer, which shows and predicts all possible gene combinations if we were to cross parents, if we know those genes. Okay, so let's go back over what a gene is. So remember that a gene is a segment of DNA, and this is one set of instructions for an inherited trait. So maybe you have genes that tell you what color hair you're going to have. Maybe you have genes on your DNA that tell you the skin color, what is the shape of your eyes. Each gene has instructions for these traits that you have. Now, it does get a little bit more complicated. You may have several genes that control hair color and several genes that control eye color and things of that sort. But the simplified definition is it is a set of instructions for an inherited trait. Now, an allele is the different forms of a gene. Like you can have blonde hair, you can have brown hair. There are different forms of what the gene could be. Now we're going to talk about dominant traits and we're going to talk about recessive. Now remember, dominant traits are the ones that they take over. You think of what the word dominant means. Is going to take over any recessive genes that there may be. So in this case, if you see a capital letter, that means it's going to be dominant. It will be that gene. Lowercase is recessive. You must have 2 recessive genes in order for that trait to show. So an example here, if we go back and think about Mendel's flowers, a capital P, purple was the dominant trait, so we would represent that by capital P. And white, the white flowers were recessive, so we would represent that with a lowercase p. These are the alleles. More vocabulary words you need to know. The phenotype is the actual physical appearance. So the phenotype of Mendel's pea plants were there was a purple flower. That was the phenotype. There was a white flower. Miss Norval has blonde hair. That is the phenotype. Miss Norval is short. That is my phenotype. You can remember that they both start with a P. Phenotype is physical appearance, and the genotype is what we actually can't see. It's what our genes say, and we're going to represent that by letters. Remember, the capital is dominant, and the lowercase is recessive. Now, when you have these genotypes, they can either be homozygous or heterozygous. Homo means the same. So, you can have 2 capital T's. This is a capital T. That is the same as this capital T. So this genotype is considered homozygous. This lowercase t is the same thing as this lowercase t. So it is homozygous. It is the same. Now heterozygous is where they are different. So in this case, this capital T, does it look like this T? No, because it's lowercase. So if it is different, it is heterozygous. Now these genotypes can tell us about the phenotype. And if you remember from earlier, the capital letter is dominant. And dominant will always take over. It's dominant over the recessive. So make sure you know if there is a capital letter, that will be the phenotype. So in this one here, capital T, this is homozygous. Because there is a capital letter, it will be tall. Here, you have 2 lowercase t's. Is there a capital? No. So it will be the recessive gene, and will show the recessive phenotype, which is short. Here, you have a heterozygous genotype, and you do have a capital letter. This capital letter will take over the lowercase, so it will also be tall. If there is at least one large letter it will always appear. So now we're going to actually get into Punnett Squares. And once again, it is a tool that predicts the traits in offspring. So if we know the genotypes, what is the probability that the offspring will have whatever trait we're looking for? So a lot of you, whenever we're doing stuff like this, likes steps. And that will help you if you do forget how to set up a Punnett square. So the first thing you're going to do is write down the genotypes for both parents. Second, you're going to separate the genes into dad's sperm and mom's eggs. You're going to have two different parents. You're going to draw a Punnett square and write the possible outcomes. So here's some examples. When you write down the genotypes, you'll have one for mom and one for dad, and unless it specifies, it doesn't matter which one's which. And we're going to be talking about freckles in this example. You can separate them into mom's eggs and dad's sperm. You don't necessarily have to draw the pictures. You'll see my examples at what I did. Then you're actually going to draw the Punnett square. You'll have mom's genotype on one side, dad's on the other. Then you will solve the Punnett square, which we will show you how to do, and then you will write the possible outcomes. So now let's go over some examples. Okay, remember here, Punnett squares, the Punnett squares we're going to do have 4 squares, so each one is going to be worth 25%. So we're going to cross a big P little p and another big P little p. In this case, the capital P stands for purple flower, and lowercase p stands for white flower. So it doesn't matter which one's mom and dad. One genotype will go at the top. Now make sure you put like a big P on the left and a little p on the right. So that one's that first one there. Now we need to put this one on our Punnett square. This will go on the left. So we have a big P here and a little p here. So this one is shown in red and this one is shown in blue. So now, like a multiplication chart, we're going to take one from each side and put them in the squares. So let's start with this square. We are going to bring a big P from the top, and there's a big P on the left. Now let's move to this square. We're going to move a little p from the top, because this is little, and a big P from the left. Now you see here, I do like that the capital letters are always in front. Now here, start from the top, bring the big P down. Then you're going to bring this little p over. And then starting in this square, bring this little p down. And bring the little p from the left. So now we have 4 possible genotypes. Now we're able to tell the probability that these parents will produce children that have purple flowers or white flowers. So remember that the genotypes, if there is a capital letter, it will always be the dominant trait. So we have a capital letter here, here, and here. We don't here. So 3 of these have a big P. So 3 of these will be purple. Remember, each square is worth 25%. We have 3 of them, so that means that they're 75% purple. And this one here will be white. So that will be 25% white. So what this means is that there's a 75% that these offspring will be purple flowers, and there's a 25% chance that there will be white. This was actually an example of Mendel's 2nd generation experiments with the hybrids. All right, example number 2, we have big B times little b. So let's say this is dad and this is mom. Capital B represents black hair, lowercase b represents blonde hair. Let's move this parent to the top. So this one is represented in red. And then we're going to have mom over here to the left. This one is represented by blue. I'm going to do this one a little faster. We're going to bring big B from the top, little b from the side. Big B from the top, little b from the side. big B from the top, little b from the side, big B from the top, little b from the side. Well, considering that the only thing that Dad had to give was a capital B, every single one of these is going to have a capital B. So that means that that is dominant. So all of the children will have black hair. 100%. This is a recessive trait. So even though Mom had blonde hair, none of her kids are, because Dad had the dominant trait that's going to take over. So 0% blonde hair. No chance. Sorry, kids. All right, last example. Big L represents long fingers. Little l represents short fingers. So we're going to cross big L, little l. That can be Dad. And then little l, that could be Mom. It really doesn't matter. So this parent has this genotype for fingers. And then this parent has little l for their genotype. Now let's solve. Bring the big L down, little l over. Little l down, little l over. Big L down, little l over. Little l down, little l over. It's like a tongue twister. Okay, so now that we have put in our squares, let's look at our probabilities. So this one has a big letter, this one has a big letter. So if they have the big letter, the capital letter, it will be dominant. So that means these two offspring are represented will have long fingers. These do not have a big L. If there is no capital letter in this all lowercase, they will show the recessive trait because there's nothing to take over. So this means that we have, these are two squares, capital letters, two squares, lowercase. So that means there are 50% long fingers, 50% short fingers. So once again, what this means is that if we were to cross these parents with these genotypes, 50% of their offspring will have long fingers and 50% will have short fingers. Now your job is to complete these on a separate sheet of paper. Go ahead and pause. Make sure you show me the phenotype percentages. You need to solve the Punnett square and tell me the percentages of offspring. And I will clarify. You're going to solve the Punnett square and find the phenotype percentages when we cross these genotypes.